Chapter 14, Kinetics. Exercise 14.29. Consider this chemical reaction from 2HBr, hydrogen bromide, to 1H2 molecule and 1Br2 molecule. Part A. Express the rate of the reaction in terms of the change in concentration of each of the reactants and products. First, H2 and Br2 are produced, so delta H2 over delta T is positive. So is delta Br2 over delta T. So option number 2 and number 3 might be correct. Options number 1 and number 4 are wrong due to the wrong signs in front of the change in concentration of the products, such as H2 or Br2. Now let's look at options 2 and 3. The difference is where we place 1/2. By looking at this chemical reaction, we see the consumption rate of HBr is 2 times the production rate of H2. For example, if the consumption rate of HBr is 2 HBr molecules per second, then the production rate of H2 is only 1 H2 molecule per second. So we need to divide the consumption rate of HBr by 2, and then that's going to be equal to the production rate of H2. That's why we need this 1/2 in front of the change in the concentration of HBr. Again, we need to look at the signs. H2 and Br2 are produced, therefore we have a positive sign in front of delta H2 over delta T and delta Br2 over delta T. HBr is consumed, so by looking at delta HBr over delta T, we notice this is going to be negative. That's why we need another negative sign in the front. And also, when we consume 2 HBr, only 1 H2 is produced, only 1 Br2 is produced. That's why we need a 1/2 in the front. Part B. In the first 23 seconds, the concentration of HBr drops from 0.58 to 0.526 molar. Calculate the average rate of the reaction. Where you just use this formula right here, it's going to be -1/2 and multiplied by the change of HBr, and then divided by the time period, which is 23 seconds. The answer is 0.00117. We need to round it to 2 sig figures. It's 0.0012 molar per second. Part C. If the volume is given 1.25 liters, and now we have this information. The first 15 seconds of the reaction, what amount of Br2 is formed. So first, this is the reaction rate for the production of Br2. We'll just copy that here. This is the production rate of Br2, also the chemical reaction rate. And then we multiply this by 15 seconds. That's going to be the change of the concentration of Br2 from 0 to this much. Therefore, at 15 seconds, the concentration of Br2 would be 0.0176 molar. Now multiply by 1.25, we'll get the amount of Br2 at 15 seconds, 0.022. Alright, you can see the chemical reaction rate is the change of the concentration of Br2 divided by delta T. So we have this equation, And we have the reaction rate given from part B multiplied by time period. We get the change in concentration of Br2. Assuming initially it's 0, then this is the concentration of Br2 at 15 seconds. Now multiplied by the volume, we have the number of moles.